Okay, 4 p.m. Thank you for joining, everyone. So I will be talking about containers. So all the modern web applications are, or any applications are deployed on containers. Um, so specifically, we will be looking into how containers work, what are containers, and the kernel features in Unix which allows containers to run like isolated or as containers. So specifically, we'll be talking about C groups, namespaces, and registry and images. So who am I? My name is Prab Simran. I have more than 5 years of experience in security industry now. I am working as a senior penetration tester in BDO. BDO is a consultancy similar to KPMG, EY, Deloitte, like that. So I mostly work on infrastructure assessments, specifically cloud, AWS, Azure, internal networks, Active Directory. So fun stuff within cloud or infrastructure. So these are my LinkedIn. This is LinkedIn QR code. I like to read and write. So this is my Medium blog. You can check that out as well. Also, this is my Hack the Box profile. I used to spend most of my time there. Nowadays, I don't usually do that. But yeah, feel free to connect. This talk is not sponsored by anyone. So yeah, just a disclaimer. So what is a container? The most important slide is this, so pay attention. So container is just a program in a running state. What does that mean is it is just a process. So when you write a C program or any program in any language basically, and when you run that, so it becomes a process. So for example, I have showcased here a Rust program. So in this, I have just declared a variable named x, initialized it with 0, and then written a infinite loop. And what this is doing is basically just incrementing the variable x with 1 with each iteration, and sleeping it for once. So I also added a sleep command inside this, because if I do not do that, it will just print at a very fast pace, and it will also consume a huge amount of memory, which I do not want it to do, because it can crash your system. So basically, container is a process like this, okay, which runs continuously. Now, in this particular screenshot, I have shown like the process, which I just ran in the previous screenshot. You can see the binary name infinite loop is running with the PID 3621. Similarly, when you run pods or containers, pod is a naming convention in Kubernetes. Pod is not a single container. It can be a single container, but it can contain more than one container. But for now, you can think of this like a container. Okay. So how they work internally? So there is a kernel feature in Unix named as Cgroups. So Cgroups are basically a feature in Linux kernel, which allows you to define resources for a specific process. So what I mean by that is, so each process requires some network bandwidth, for example, some input output, some memory, some CPU cycles. So C groups allows us to do that. If you create a C group in Linux and for example, configure that to use a specific amount of RAM, which we will be seeing that in the next slides. So you can make sure that the processes which are attached to that particular C group can only access that particular amount of resources. Okay. This is essential for containers, because if you allow your container to consume as much resources as it like, so it can crash your system. So we don't want to do that. for example, so here in the first step, I am creating a C group named as test. The type of the C group is memory. So the command which I'm using is cgcreate. So what is basically doing here is I just created a C group named test, and in the next command I am setting the memory limitation or memory configuration for that C group to 4 MB. So this particular C group can only provide 4 MB of RAM to the process to whichever this will get attached to. So in the next step, there is a open source project on GitHub named as memeat. So memeat is a memory testing tool which you can compile and use on your own systems for memory stress testing. So how does it work? You just compile this and run this binary with the CLI parameter of the amount of memory you want this process to consume. So what I'm doing here is I am executing this memeat process with the C group of test which I just created in the previous steps attached to it, and I'm specifying the amount of RAM as a parameter to only consume this amount of this much amount of RAM. So this process will consume only 1 MB of memory, and in the screenshot you can see it runs successfully, and it also shows will eat this much amount of RAM. So basically 1 MB of RAM it consumes, and it is still running. It didn't got crashed. Okay. So with 1 MB works fine. Next, but what if we ask this process to consume 5 MB of RAM? So what happens in this case is this crashed. Why? Because we attached a C group which we created previously to this process, and that C group only allowed 4 MB of RAM because we configured it like that. So when we tried to start this process with that C group attached, it was unable to run, and it crashed. It got crashed. Okay. So basically, that is a use case of C groups that is mainly used for resource management. Okay. Next is namespaces. Namespaces is also a kernel feature in Unix that is usually used to isolate resources for the processes. So not resources, isolate the environment for the processes, allowing them to operate in their own sandbox environment. So for example, when you run containers, you don't see the processes which are running on host operating system. Why? Because the namespace is different in which with which your container is running. Also, there can be different types of namespaces. One is PID namespace, which I'm just showing example for that here. So in the step 1, I am creating a namespace, a PID namespace, and I am running the process bash and attaching that namespace to it. So basically, similar to container, when you get a shell inside a Ubuntu container, for example, so you get a you run a bash to run commands or interact with the container file system. So that container also has a its own namespace. So similar thing I'm doing here, and when I ran this ps-aux command in the first screenshot you see in the screen, I am only able to see the processes which are within the container, so not the host processes. Now you can list your namespaces. So for listing the namespaces, the command is lsns. So that will list all the namespaces which are created by some other Docker or maybe some other containerized Podman or Kubernetes. So in the third last and second last line, you can see the namespace which I created in the previous step. So this ls is for listing files, but lsns is for listing the namespaces in the system. Um, now, just for example sake, you can have two containers running in Docker with same namespace. So basically, in the first command, I am starting a container, a regular Ubuntu container, and in the second command, I am again starting a regular Ubuntu container, but with the same namespace, the same PID namespace of the previous container. Okay. So what that means is both the second process, the second container, um, all the sorry, the both of the containers can see each other processes. So if you run an application in one container, the other container will also able to see that application or the process whatever you ran in the other container. So I ran the sleep command in the second container on the right side of the screenshot. Sleep 500, and on the left hand of the screen you can see the other container which is having same namespace attached to it can see the process. So in a nutshell, namespaces are for isolation. Okay. Next, images and registry. So registry is just a server which hosts file system for containers. Container images are files which just like Unix files, regular file system, it has all the directories, bins, temp, opt, all the directories. And registry, it just serves those files for each container image. Now you can list your images in your system using docker images command. For example, I have one image in the screenshot. You can see this is Ubuntu image. You can see that the tag is latest, image ID is that E0F16 something, created 3 weeks ago, size is that 78.1 megabytes. You can also save this image as a file on your system and then import that later on if you want to. For saving this image, you run docker save command with the -o as output parameter, and it will be saved as a tar file which you can extract later on. So that's what I did in the next screenshot. I downloaded a container image and then extracted the file. So inside the file, I got different types of files. I got directories, which is the blobs directory which you see, and I got JSON files and some other directories. So JSON files are mostly metadata. So they contains information like what changes were made to each. So for example, when you make some changes in the container image and you push the image that after changes to the image, so you get a new tag and new image. So basically it is like of a versioning system like Git. You can think of this like that. So whenever you create a new change or delete some file in the container image and then commit that, so you get a new, you add a new layer to that base image. So you see these SHA hashes, SHA-256 hashes. All these are image layers, and each image layer had made some changes to the base image. Okay. Also, if you are running your local registry server for container images, you can download the whole container image layer by layer. What I'm trying to say is, so each container image have many layers. So for creating a full-fledged image, instead of downloading a whole image like with a single command docker pull, you can use the API, registry API, to download the image layer by layer, and then you can combine that to get the full-fledged image. So that's what I am showing here for downloading the layer one by one. you can use this command, um, and the each layer will be downloaded. Then you can combine all of that to both of these layers to get the full-fledged image as an original image. Now, those were kind of three basic pillars of containers, how they work: namespaces, cgroups, and images, just regular files. So what is the difference between, you might have heard about Docker and Kubernetes or Podman. So what is the difference between Kubernetes and Docker, because these are most famous or well known. So Docker, the scope of Docker, for example, I have I have showcased here. Scope of Docker is a containerization platform. It is basically created for single node or single system, whereas Kubernetes is for managing containers. Docker is for managing like applications, like micro services, whereas Kubernetes is specifically for managing containers. Kind of, you can think of this like that. Docker build and ship applications as containers. Kubernetes run and manage large clusters of containers. So again, managing containers. Core focus for Docker is how to run a single container, whereas for Kubernetes is solving the problem of how to manage thousands of containers. Docker has some keywords like Docker Engine. These are separate components: Docker Engine, Docker CLI, Docker Hub. Docker Hub is the registry, by the way. You can also create your own images and upload that to Docker Hub. So it is your public registry. This is like a GitHub, so feel free to upload your images there. In Kubernetes world, we have some keywords like pods. Pods are similar to containers, but not exactly. Pod can contain multiple containers, or it can have a single container as well. Services, deployments, and ingress. Just don't need to focus on these. Just these are keywords for now. So basically, in nutshell, Docker is, if you want to have an analogy, if Docker is a car, Kubernetes is a traffic management system, which manages different cars. So think of that as an analogy. So key learnings. So we saw what are containers. Container is just a process, very important to remember. How do they internally work? They just use Cgroups and namespaces. So that is the basics. Misconfigurations can occur, like for example, I showcased if two containers are having same PID namespace attached to it. So one container can interact with the processes of another container. So very bad if you are doing that for applications which should be running isolated. So that these types of misconfigurations can occur. So Mitre attack has a container matrix specifically for container related attacks. You can go to their website and check out this matrix. So TTPs are similar: initial access, execution, persistence, previous escalation, defense evasion, credential access, discovery, later movement, impact, and then they have their sub techniques and procedures. Now, these are some bug bounty reports which were reported to HackerOne. These were basically container related attacks, and these were triaged. So these are valid reports. You can read about them. For example, I can show you ET Wi-Fi. So in this particular report, someone found a registry which was not authenticated or publicly exposed. So that person was able to download images, read the files inside the images, maybe find some sensitive information like password secrets inside the images if those were hard coded inside the software. So you can read this and get a gist of like how containers can be attacked as in the infrastructure. So this particular finding map to this particular technique T11333, that is external remote services, because the registry was publicly available without any authentication, and the tactic is initial access, and you can read more about it here in the Attack Mitre website. Similarly, the next one is for container escape. Container escape basically means when you are able to read host file systems or break out of to the host completely. So again, very bad thing to happen in production. So you can read about this as well. So in this particular attack, the tester was able to read files on the host operating system. And it maps to T1611 escape to host. And this is a privilege escalation or defense evasion type of attack tactic. References, these are some of the blogs which I wrote previously for containers. All the things which I discussed are available here. You can go through them if you are interested in containers. That is pretty much it. If you guys have any questions, feel free to ask.
Maybe a small question
Yes.
regarding escape to host. When you escape, for example, I have container, my own, I deploy it to AWS, and if you can escape to host, can you read all other containers?
Very good question. So in managed cloud providers like AWS, so they have their own Kubernetes service, AKS. So yes, there is a possibility that other users' containers are also running. I'm not exactly sure, but I'm 100% sure that if multiple developers are using same AWS account, like a organization account, then yes, you can, if you are able to break out of a container in the Azure K8s, AWS K8s or any other, then you will be able to see the containers which are running, which other developers have started. But I think there is isolation per account in cloud. Otherwise, it would be very bad. One organization is reading files of another. No. But for sure, yes, if the account is same. Any other questions?
Apart from lack of namespace isolation from the host, what other points of entry or privilege escalation tactics are being actively exploited?
Many. For example, if you are mounting volume mounts, for example, specific volume mount. For example, if you mounted your home directory of the user, then container can read the SSH configuration files from the host. If you are familiar with K8s like Kubernetes, then you can be having misconfiguration in role-based access control. So in Kubernetes you have service accounts. So different pods can have different service accounts. So if your service account is having, let's say, permission to read secrets maybe, or and there is a sensitive secret, By the way, secrets are not encrypted in Kubernetes. They are just base64 encoded, so they are not encrypted. So disclaimer. So yeah, role-based access. It is similar to IAM. Like in AWS, you make sure there is a least privilege principle you follow. Only provide those privileges to identities which is required. Similarly, for service principle, you should provide only those privileges to the service accounts which is required. If you provide, let's say, privileges to create new pods, so someone can create a pod with more privileges, let's say attaching volume mounts or attaching more capabilities. I didn't touch on one topic, that is capabilities. That is like system calls or group of system calls. Yeah, but I was having 20 minutes, so thank you.
Speaking of which, thank you very much.
Thanks.
Well done. Well done. Thank you.